die. It's very tragic. Other damages happen, such as houses being broken, and even if the houses don't completely break, the infrastructure is changed and will need to be repaired. Many lives are ruined after an earthquake, as we see in Japan and in California. Our group has an idea to help one of the major problems that happen in an earthquake, and that is lack of clean water. We are planning on building a tank.
We interviewed a couple who experienced the 1989 Loma Prieta earthquake, which had a Richter scale value of 6.9. In this particular earthquake, the pipes did break and water was gone for about a week. Now, the couple had to rely on bottled or boiled water, which was really hard, but we think our solution, Project Dome, will come in handy in this, as it will be much easier and much faster to use.
Okay, so our tank is going to have an outside layer, which is metal, so that it'll be strong, and a plastic layer on the inside for extra protection. On the very inside, we will have a fabric tank made out of Gore-Tex fabric because it was waterproof and will act as a balloon if we fill it with water. This way, it'll be impossible to break because if something is rigid, it will break more easily than if something is fabric. Kind of like trying to break a marshmallow in half versus a stick. This will allow the dome to be more strong and more durable for an earthquake. The water will come out from the tank in a pipe, which will at the end has a filter to filter out the water. This will make sure that our water is safe under drinking and will ensure safety during an earthquake.
Found out that the average person uses two liters of water, 2 quarts of water each day for food and sanitation, and 2 quarts of water for drinking, which that makes 1 total gallon. And just to be safe, we gave each person 1.5 total gallons. We're using this product for one week. The family will be using it for 1 week, and because that's the approximate amount of time that the water pipes will be broken. So the tank will be a 125 gallon tank, and just keep in mind that it can be the tank can be extra water, can hold extra water or reduce water according to the size proportions.
Okay, so here's my 3D model. See, it's concrete on the outside, and it has this pump right over here, and it has this plastic layer on the inside. And I also put this plastic lining just so that I'll be able to test to see if our inner layer will break or not, since it's going to be a fabric. What do you guys think?
I think it's good. It's really good.
Yeah, it's fine, but I have a question about the pump. I don't exactly know how it works.
Oh, okay. The pump is basically going to be a PVC pump where you push it in and it'll kind of come out. We might also add an electric pump just for refilling and filling it, and yeah, that'll help maintain the cycle of keeping the water clean.
And so, wait, how do you know when the water is still fresh?
Oh, well, like, we should wait about 6 months. 6 months is a good time to replace the water because it must have gone bad by then. Like some sort of mold or mildew must have got in there. So you might want to get it cleaned out or something like that. And we're also going to have a filter over here at the very end, so that way when it comes out, it'll already be filtered so that there won't be like something
So it's like that in there. It's like a double check. So like the inside water is pure and you purify it again.
Yeah.
Wouldn't it be better if we maybe added like some water purification tester that indicated when the water needed to be changed?
Oh, that's a good idea. Like kind of like the size of a pen.
Yeah, about. So we can just like dip, check. Oh, it's good. Like that.
Yeah, it's pretty nice.
Yeah. And also, why is the pump going straight out? Why can't we just? Because it'll be more accessible like this.
Yeah, that's a better idea. Maybe you should keep it like this. That way they'll be able to pump it out easier.
Yeah.
Yeah.
Cool.
Okay, that's a wrap, guys. 1, 2.